Much for clicking on this video. We are looking into acid, base and salt series, but in this video we are looking into acid. So I have my own expectation from you as a student. That is what you should be able to do at the end of this video. As you can see on the screen, you should be able to define acid and group acids, and also you should be able to describe methods of preparing acid and give properties of acid. That is my expectation from you, and also be able to give two general uses of an acid. And in this video, I actually group this video into two sessions, and the first session has to do with introduction of what acid is, and it has its own questions that I am expecting you to be able to answer. So my expectation is high, and I urge you to pay good attention to this video so that you will not have problem at the end of this video. So I'm expecting so much from you as a student to get this question accurately that you are seeing on the screen, and make sure you answer them at the end of the session. So at that time, you need to pause the video and check if you are able to answer the questions. Remember, all the answers are inside this video. Okay, let's start with the definition of acid. An acid is a substance that is able to produce hydrogen ion as the only positive ion. Some people can say it is hydronium ion, some people can say it is ozonium ion, some people can say it is hydrozonium ion. These last three I used, they are the same thing, because hydrogen dissolving in water will give us hydronium ion. Some people call it ozonium ion, some people call it hydrozonium ion. And mind you, it must be the only positive ion in that water. So when we have more than one positive ion, something like we have hydrogen ion and we have another metallic ion, something like sodium ion, calcium ion included with hydrogen ion, so we will not call it a typical acid. It is going to be an acidic salt, so it is not a typical acid. So we also need to know that it is not all substance that will give hydrogen ion in water. For instance, we have something like methane. This methane has 4 hydrogen atoms, but it cannot even release one hydrogen atom to form hydrogen ion in water, so it is not an acid. But we have ethanoic acid. Yes, we call it ethanoic acid. It is an organic compound just like methane, and it can be able to produce hydrogen ion when it dissolves in water, so we call it an acid. The same goes with hydrogen chloride gas. Hydrogen chloride gas is a typical acid because when it dissolves in water, it is able to produce hydrogen ion as the only positive ion, as you can see on the screen. So the hydrogen ion will dissolve in water to give us hydrozonium ion or hydronium ion or even ozonium ion. So you need to know that this equation that I've been writing is splitting this ionic equation, that shows that this acid has dissolved in water and dissociate. We call it ionization in water. Okay, we have 3 people that actually gave definitions for acid. We have Arrhenius, Bronsted-Lowry theory, we have Lewis acid-base theory. Yes, they do ask us this question, and I want you to grab information here. It is very, very important. So an Arrhenius theory try to tell us what acid is as any substance that is capable of increasing the proton or hydronium ion concentration. That is what he called an acid. So a substance that is able to reduce the concentration of hydrogen ion by introducing hydroxide ion, we call that a base. That is according to Arrhenius. Let's just look at an acid of this. We have something like hydrogen chloride gas. We can even include ethanoic acid. So a base, when we go to class of base, we are going to look into some base. Although I have a simple base we are going to work with, which we call ammonia here in this video. So let's look at the other definition of acid. Bronsted-Lowry theory. He is defining acid as a substance that is capable of releasing a proton. Remember, the other one produces proton when dissolved in water, but this one just produces proton whether it's being dissolved in water or not. But anyone that is able to accept proton, we call that a base. And a sample of that is seen as ethanoic acid. The hydrogen ion is actually a proton, so it's able to release its hydrogen ion, which is a proton, to water. So this ethanoic acid defines acid of Bronsted-Lowry. Remember, this is in water. The first one I did also in water. Now let's look at the third definition. According to the third definition, what we have here is that there is water shown here, and if you look at the two dots that are on oxygen, we call them lone paired electrons. And when hydrogen ion have lost electron, it will come and bond with this lone pair electron. Now this water is able to give out its lone pair electron to be shared by hydrogen ion, where hydrogen ion is able to accept electron pair. That makes hydrogen ion an acid, because it can accept electron pair electron. That is what Lewis is trying to tell us an acid is. In further note, he actually extended this idea by moving away from a substance that only dissolves in water. He even told us that we can actually know that it is just that a Lewis acid is able to accept electron, and a Lewis base is be able to accept or give out electron pair. So when two of them comes together, we are going to have a coordinate covalent bond. And you know, you have done your covalent bonding, coordinate bonding, or another way for it is dative bonding, or we can call it adduct. So he extended this reaction away from water alone. That is something that only dissolves in water to produce hydrogen ion. He's trying to tell us that as far as ammonia is able to give out its electron paired electron, it is a base. And as far as ethanoic acid is able to give out its hydrogen ion, which is able to accept the electron pair given out by ammonia, it is an acid. We can see other things in some of my questions in my objective question, where you're going to practice most of these to identify who is who. But if you come to the right hand side of the equation, that is the product side of the equation, you are going to notice the place you see negative sign. Those negative signs represent the Lewis conjugate base, whereas the positive sign, which is the ammonium ion, represents what we call the Lewis acid conjugate. I hope you get that. Okay. So here I just dropped some of the Lewis acid representative and Lewis base representative, as you can see on the screen. So when they come together, like hydrogen ion coming together with a base which is ammonia, we will have an adduct called ammonium ion. And we also have SO3, which is sulfur 6 oxide, bonding with water. Here, water, remember that water, as I showed before, has a lone pair to give out, and it's going to give it out to SO3, and they form an adduct, which is what we call tetraoxosulfate 6 acid. So you get that. So we are entering to the next session. I want to ask you a question. Do you think you are able to answer the question in the previous one? So I will urge you to also look at these questions and see if you can be able to answer them at the end of this session. So we have classification of acid based on the sources of the acid. That is where we can get them. We have degree of ionization of acid. That is at what rate or degree will that produce hydrogen ion. We're also going to look at the number of replaceable hydrogen ions of the acid present per molecule. Also going to look into the amount of the acid in gram or in mole present in an acidic solution. So let's start with sources of acid, that is grouping acid based on its sources. We have natural and we have mineral element. The one that comes from natural sources, we actually render them as organic acids, and we can also call them natural acids, and they are found in plants and animal. And I have COOH here. The C must be bonded with 2O, not more than 2O. The C must be bonded to only 2O, that is 2 oxygen, and one of the oxygen must be bonded with hydrogen, and the number of hydrogen bonding with oxygen determines the number of replaceable hydrogen. And the same thing even goes with all other oxy acids, but for this one we are talking about organic acid. For us to say that this is an organic acid, the carbon must be bonding with only 2 oxygen at a time. where one is by double bond, one is by single bond, which is bonded with hydrogen, which determines the number of replaceable hydrogen. I hope you get me on that. So we have example of organic acid like ethanoic acid, lactic acid, amino acid, citric acid, fatty acid, ascorbic acid, formic acid. This formic acid is important to me because it is an ant sting, so you need to look into that. So we have some sample of them as you have here. Then if you go back to the question, I believe you can answer questions from this. Okay, let's go on. So we have mineral element sources, and these mineral element sources, we can call them synthetic acids, we can call them inorganic acids, we can even call them artificial acids. But there is something here. In organic acid, there is one of the organic acid that I do not mention there because I don't need to put it there. Hydrochloric acid. It is found in the gastric juice of a human being, but it is actually an inorganic acid, so I do not put it in organic acid, despite plants or animal might produce it, but I do not classify it as that. So when we are looking at mineral element sources, we call it acid manufactured from minerals or elements are called inorganic acid, as I have just said. And examples of them include hydrobromic acid, hydrochloric acid. This hydrochloric acid can be manufactured by plants or animal, but majorly, let's put into this, the hydrochloric acid are manufactured by animal, human being, in the gastric juice. Yet it is not classified as organic acid because it does not have a direct carbon oxygen, direct carbon hydrogen, as I showed earlier, or carbon bond. So because of that, it does not have, it is not called an acid. So we go with hydrofluoric acid, triazonitrate 5 acid, and so on. So we can also classify these acids. See what I mean here, that C must be bonded with O and another O. One of the O is in double bond and the other one is single bond, which the O is bonded with hydrogen. It must be like that for us to call it an organic acid. And this bond C bonded towards it must be bonding with a hydrogen or carbon. If it is bonded with another oxygen, that means that there are 3 O's, there are 3 oxygen there, which does not make it an organic compound or organic acid. Hope you get that. So we have, for mineral acid, we have strong and weak acid based on the degree of ionization. So for strong acid, they ionize completely in water, that is, they dissociate completely in water to produce the hydrogen ion they are producing. So they are able to release the hydrogen in water. So examples of them include hydrobromic acid, hydrochloric acid, triazonitrate 5 acid, and so on. Here I do not mention hydrofluoric acid because hydrofluoric acid, despite being in the line of hydrochloric, hydrobromic, or hydroiodic acid, hydrofluoric acid is not a strong acid. Now the question is, why is it not a strong acid? It is not a strong acid because it cannot ionize in water completely. It finds it difficult to give out its hydrogen due to the strong bond between hydrogen and fluorine, which we call hydrogen bonding. So it is not easy to release hydrogen to oxygen, which fluorine is greater than oxygen in right sense. So hydrogen cannot be released to water easily by fluoride ion because fluoride ion is stronger and highly electronegative than oxygen. I hope you get me on that. So in this, we have other ones like the organic acid. As you can see them, you have organic acid, and those organic acids are also weak acids. Okay, we go monobasic acid. We have monobasic acids, and monobasic acids are those acids that has only one replaceable hydrogen per molecule of the acid. So examples of them include hydrofluoric acid, diazonitrate 3 acid, and we can even go to diazophosphate 1 acid. Be careful. I know when you look at this diazophosphate 1 acid, you'll be asking, it has 3 hydrogen here. Why is it that it is not a tribasic acid? So let me introduce something for us. See this, we have the rule I stated before that the middle element must be bonding with a double bond oxygen and a single bond oxygen, and the number of hydrogen bonding with the single bond oxygen determines the number of replaceable hydrogen. So if you look at this plus one, this is diazophosphate 1 acid, has only one OH. So we are taking it as the only replaceable hydrogen. The two H atoms are not included. I hope you get me on that. Let's go for the next one. So the next one is diabasic acid. What do we even mean by diabasic acid? Diabasic acid is a type of acid that has only two replaceable hydrogen per molecule of the acid. Example of them include tetrodosulfosic acid, triodosulfosic acid, we have ethanol dioric acid, we have triisophosphate 3 acid. Mind you, it has 3 hydrogen, yet the only replaceable hydrogen there is 2, as you can see in the middle of this my diagram that you are seeing here. We also have tribasic acid. This tribasic acid contains 3 replaceable hydrogen per molecule of the acid. Example of them is tetraisophosphate 5, and we have citric acid. And I'm giving you an assignment to find out the chemical formula of citric acids. So we move further. I need you to recall this diagram again, that C is bonded with double bond O, is bonded with one single oxygen and hydrogen. That is an oxy acid to be an organic acid. The C, the last bonding part, should bond with either hydrogen or carbon. But if we are looking at something like triosocarbonate 4, this C is bonding with another oxygen, making it 4 oxygen, and that other oxygen is also going to bond with another hydrogen, so it doesn't make it an organic acid, rather make it an inorganic acid. So we still have other ones, something like SO, SOH and SOH. Then we are having 2 OH here, so it means that triodosulfate 4 is a diabasic. The same thing goes with S bonding with O, S bonding with O, bonding with OH. So we are having 2 OH. So we have 2 replaceable hydrogen from triiodosulfate 6 ion. Hope you get me on that. So the same thing I have said concerning the phosphate 1, phosphate 3, and phosphate 5. The same thing goes with the triazonitrate 5. It has only one replaceable hydrogen because it has only one OH. I hope you get me on that. So we can go further to look into amount of acid in an acidic solution. So we have one concentrated acids, and we also have one we call diluted acid. Then what do we actually mean by concentrated acid, and how are we going to put it up for us to understand? When we say concentrated acid, we are looking at that number of acid, amount of acid, either in gram or mole of the solute present in the solution. So the acid must have enough acid solute, more than water, as the solvent. That is how we go with it. But for it to be called a diluted acid, it means that this acid has less acid solute than water solvents. Okay, I want you to know that there are ways of preparing acid. We have one to be acid can be prepared by direct combination of the constituent element or compound. So we can have elements coming together to give us an acid, like hydrogen bonding with chlorine to give us hydrogen chloride gas. But when we dissolve it in water, it gives us a strong acid. So we also have SO2 bonding with H2O, that is sulfur 4 oxide bonding with water, reacting with water will give us triisosulfate 4 acid. We can still do the same thing with sulfur 6 oxide to give us tetraisosulfate 6 oxide. Now we have the solution of acid anhydride. Here it is the same thing, as it's very close to direct combination, but this direct combination is a special direct combination where water is one of the substance that is bonding with the other. So we have it as the solution of an acid. We still have another one, reaction of stronger acid displacing sort of weaker acids. So here what we are saying is that a stronger acid will be added to a sort of a weaker acid. Something like, it's not compulsory that the weaker acid is a weak acid. I want you to get that. It's not compulsory at all. It's not compulsory. We can actually use that to get acid. So we have another one, displacement reaction, where something like fluorine will displace hydrogen chloride gas and it become a salt. It become an acid. I hope you get me on that. So let's look at physical properties of an acid. We have sour taste present in some fruit. It's a simple property of a dilute acid. So the sour taste we notice from some unripe fruits actually point to the fact that they are still acidic. The acidity is still high, so we are able to get it. Mind you, this does not warrant that when you come to chemistry lab that you will be testing acid with your tongue. No, you can only do that if your teacher asks you to do that, which I believe most teachers will not ask you to do that. So please don't do it. But if you are unlucky or unfortunate that the diluted acid enter your tongue, please make sure you rinse it with water over and over. It is very, very advisable. And the solution of an acid will change the color of litmus paper to red, and also will change the methyl orange to red. So if you add methyl orange inside an acid, it will change to red. So I need you to know that they are actually electrolytes, that is, they can conduct electricity. Yes, they are able to conduct electricity, and also the concentrated form of strong acids are corrosive. But mind you, don't be deceived. Even whether it is strong acid or weak acid, please don't joke with acid. It won't pay, because acid will always be acid. Whether it is a weak acid or a strong acid, it is possible that it may cause irritation, so you should be careful with that. Chemical properties of acids. We have the react with base to form water and salt. Mind you, this is very, very important. The neutralization reaction between an acid and base is very, very important. We use it to, they repeat this question over and over. If they can't be able to ask that question in your theory question or objective question, they will bring something like that in the practical form. I hope you get me on that. So we have liberation of hydrogen gas with highly electropositive elements. As you can see at the right hand side, the Kena, Baka, MgR, Symphony, SS now, that is lead and tin. So all those ones are above hydrogen, so they can be able to displace hydrogen from acid. So we have liberation of carbon 4 oxide from triazocarbonate 4 salt. Listen, these three properties are well known by every chemist. So you as a student should put these three things in your head and be able to represent it using equation. If it is me asking you a question in exam, is a sure thing that I will ask you to make use of equation to demonstrate your answer. So you should study this and study it properly. So let's look at general uses of an acid. It is used as an electrolyte. You can also use it as flavoring and preserving food. We even use it as reagents in the laboratory. We also use it as purification of substances. I really thank you for staying with me to this point. It is not easy for you to sit down and watch this video to this point. So I really want to congratulate you. You are actually strong. So thank you very much for watching this video to this extent, and don't forget to subscribe, and don't also forget to click the notification bell if you are new to my channel. It is very advisable to share my link on your social media platform. Speak about me to people around you that are doing chemistry, and thank you very much for doing that for me, and may God bless you. And I wish to hear from you. You can comment on the comment box and ask your questions if you are confused anyway. Remember, I actually have a Google form question. If it is not released immediately, just come back after 2-3 weeks. You will see the Google form question about acid. You really need to answer. It is going to be important to use it to checkmate your work. Then I need to ask you a question. The questions that you wrote down, do you think you can be able to answer those questions? If you cannot, watch this video again, and it will be very advisable for you to always watch my video at least 4 minutes online before you download it. Do this to help me grow.